In this session, we will discuss time-independent Schrodinger equation. For this, let us consider a particle of mass m, energy E, and linear momentum p moving in a potential field V. A moving particle has a wave associated with it. So let xi represent the wave function and v be the velocity of the wave, so that we can express the wave equation as dou square xi by dou x square is equal to 1 by v square dou square xi by dou t square. Now, the solution of the wave equation can be represented as xi a e raised to negative I omega t minus kx. Now, let us differentiate this equation with respect to x. So the derivative will be dou xi by dou x is equal to this quantity, which is xi, multiplied by negative I times negative k, which is ik. So the first derivative with respect to x is ik xi. Now, differentiating this equation once again with respect to x, we have dou square xi by dou x square is equal to I square k square xi. Since I square is negative 1, we will modify this to be written as dou square xi by dou x square is equal to negative k square xi. Now, k being the propagation constant can be expressed as 2 pi over lambda, so that this equation will be modified as dou square xi by dou x square is equal to negative 2 pi by lambda square xi. Lambda, the wavelength, can be expressed as h over p, where p is the linear momentum and h is the Planck's constant. So that we have the equation modified as dou square xi by dou x square is equal to negative 2 pi over h by p square xi. 2 pi by h is a reciprocal of the reduced Planck's constant. So 2 pi by h is 1 by h cut, and this p, 1 by p is available in the numerator. So the equation becomes dou square xi by dou x square is equal to negative p square xi by h cut square. The total energy of the particle can be expressed as the sum of kinetic and potential energies. So E is equal to p square by 2m, the kinetic energy, plus v, the potential energy. Now, rearrange this equation, we have p square is equal to 2m E minus v. The value of p square can be substituted in this equation, so that dou square xi by dou x square is equal to negative 2m E minus v by h cut square xi. This is a time-independent Schrodinger equation which can be modified and written as dou square xi by dou x square plus 2m E minus v by h cut square xi is equal to 0.